Hi there. Thanks everyone for joining. My name is Daniel Geeta. I'm the Artificial Intelligence Solutions Set Lead for Qualitest, and I'm joined by my co-host, Chris.
Hi there, I'm Chris Lovett and I'm the Solution Architect for Qualitest. I'm based over in California.
So, a little bit of context on Qualitest. We are the world's largest pure-play quality assurance software testing company. Quality assurance is all that we do. We provide a team of specialists cutting across sectors, industries and services, and we provide expertise in all types of software testing, from functional testing through non-functional testing types. We've been working in the industry for a number of years now. We are independent and trusted. We have a huge pool of experts globally. We have large amounts of expertise in different domains. We offer outcome-based testing, managed testing services, and global services delivery. We want to talk a little bit today about some of the rising challenges that we see with rising demands of consumers, mean that the demands for software quality are constantly evolving. And quality as an industry is needing to continually adapt to change whilst not actually jeopardizing the quality throughput. DevOps processes are being adopted to meet consumer demands for ever faster content publication, but we still need to ensure that all the testing is done. And testing is starting to become unwieldy. And what we want to talk about is how can we use AI to try and trim back some of the debt that testing is starting to bring. We're going to talk, first of all, about why demands are evolving at the moment. Then we're going to talk about what are quality engineering and DevOps. Then we're going to talk about risk-based testing and how historically it's solved similar challenges and where it still has a few things that need to be addressed. We're going to talk a little bit about how shift left and shift right work, and then we're going to talk about how AI can help inform shift left, shift right, and test process improvements. So in the last handful of years, we've seen a few changes in the industry. We've seen the rise of predictive analytics, cloud computing, deep learning, Internet of Things, big data, this explosion of very data-intense processes. At the same time, we've also seen consumer shift. People want more and more content more rapidly than ever before. And the two have combined to give us a need for more automation and more personalization of our applications. We want our applications to do more for us. We want them to be able to cover all the bases for us, but we want them to do it in an innately personal style. The pillars of quality that govern our applications have changed as we've done this. It used to be that all we really cared about were the functionality, security, and performance of our applications. Did it work? Could I reliably put my data into it, and did it work fast enough? But with this drive of automation and personalization, we're also seeing a much greater need for intelligent capability of the applications. I want my app to do more for me. I want my software to do more for me. I want it to take my decisions and make them in a better way than I could. I want a better experience. I don't want the same experience everyone gets. I want the experience tailored for me. Building and testing all of these gives us a problem. We're now having to test more assets of our application than ever before in less time than ever before to meet the demands of our consumers. This gives rise to the need for new types of engineering and DevOps methodologies.
So quality engineering is one of the terms that is becoming more widespread throughout the industry. That's came as part of a drive towards following other engineering practices. So historically, testing was very much an inspection level and very opportunistic. You would have your development phase and that would be handed over to a separate software testing phase. As things have evolved, everyone's moving more into the quality assurance model, where this is where you're adding a lot more processes and a lot more control around your quality. You're driving it through the development, but it's still more of a tactical approach. And then where we're moving to now is more towards this quality engineering model. And this is from in putting in disciplines, putting in knowledge management practices, continuous improvement, having complete DevOps models to ensure that quality is not only factored in during the development or the testing phase, but it's factored in from the very beginning and all the way through. Everything's future-proofed, everything's of a high quality to meet the demands of the consumer. And quality engineering falls as part of the DevOps model. Now, DevOps is all about bringing together development, QA, and operations. It's a natural extension to Agile. Agile was all about bringing development and QA together. DevOps is just bringing operations into that fold. And the idea behind this is to bring in shorter feedback loops, be able to adapt to change better, have more frequent releases. And quality engineering fits into this model because to be able to have these short feedback loops, to have these frequent releases, you need to have quality throughout the entire process, end to end, and it needs to be engineered into the product, not thought of as an afterthought. So as part of that, just want to briefly touch on what we mean by a DevOps process, just to ensure everyone's on the same page. So initially what you've got is, if you're looking at Agile development, all Agile development is about is automating the tests of, automating the continuous integration of code back together. It's doing this continuous development, merging developers' codes together and then testing that as a single unit. As we're automating more and more, we're automating the build process, we fall into that continuous integration methodology. Then as we've got automated tests in a fully functional test environment, we're doing automated end-to-end testing. There's an automated deployment to that. We're falling more into this continuous delivery model. And then finally, to move towards the DevOps model, you've not only got this automated process through writing the code to it being tested, to it being deployed to a test environment, to it having end-to-end tests ran on it. It's then deployed into a release environment, into production environment. That production environment is monitored to make sure that there are no impacts to user behavior, and you've got this rapid flow from planning through to monitoring the production system that again feeds back into the planning process. And this is where the quality engineering feeds into the DevOps practice. So when it comes to doing functional testing in DevOps, there's effectively a simplified model. There's 3 levels of testing. Your unit tests are what's your fast, stable, measured tests. You can execute thousands of them in a very short amount of time. But at the same time, they're also very tightly coupled with the functionality of the code. And that doesn't give you the business assurance that your application is necessarily doing what your users want it to do. On the opposite end, you've got your system tests. Now, these are a lot slower. They're a lot more unstable. They require a lot more maintenance, but they do give you a much broader coverage. They give you a much better understanding of whether your system's behaving the way that your users are expecting it to. And then this is where we come up with the terms shift left and shift right that we're going to be digging into more and understanding more about how AI can help with this, where effectively shifting left means moving more of your testing into the unit level, which is fast and stable, but has got a very granular scope, or shifting right into the system testing level, which is slower, more unstable, but gives you the greater assurance that your product is behaving how you're expecting it to. And the drive towards whether you should shift left or shift right, most of the industry, there is a desire to shift left due to it being fast and stable and low maintenance. But businesses are demanding not only that, but also high levels of assurance, which is why there's still this end-to-end QA process. So unit testing meets the top 3 demands, the fast, stable, and low maintenance. System testing provides you the assurance that you need, but then how do you strike the balance there? And to strike that balance, you need to understand what the value of your tests are. So now the big question is, how do you know which of your tests are adding the most value?
So just before we go on, we should put a brief poll on there that we'd like to get some information from you guys on where are you currently seeing the bottlenecks in Agile process?
So I don't know if you can see the results. I'll just read them out. So we've got 18% were requirements, user story capture. 18% were task estimation and backlog grooming. Others, 18% feature development, and 36% said test execution. And finally, 9% on release quality. So test execution came top there.
Great, thanks very much. So that takes us quite neatly onto our next question. Are we actually over-testing? with the rise of DevOps, many organizations are performing much more comprehensive continual testing in the applications than ever before. And this is great. We're ensuring that the quality is there. But are we possibly over-testing? Are we testing too much because there is this concept of shift left, shift right, but we haven't necessarily mastered it yet? Even with some of the high-powered automation tools you get today, with proactive shift left and shift down, widespread execution of testing is a very slow and very cost-intense process. And this is purely due to sheer saturation of what we're trying to test, right? We've talked about how we're adding more features, we're adding more functionality, we're trying to test more types of things. We're trying to test the same things in different ways. For instance, we only cared about the functionality, performance, security. Well, now we're more interested in the experience as well. That's just on the features we had. I've now got to test all this new stuff the same way. With so much testability, the surface of our applications to examine for quality is so high. Is it possible we're testing too much? Can we shift some things left that do not need to be handled right? And should we be shifting some things right because we're trying to run too much in the left-hand side? Is there a way that we could start to target our testing more effectively to find out what we're looking for? Historically, we adopted the technique of risk-based testing when it became apparent that testing an entire application was just not feasible, either because of execution times or because of the duration it would take to test or the number of combinations that would be required. We adopted a technique of risk-based testing. We looked at the likelihood of a part of an application to fail and the impact to business if it does. The higher the likelihood alongside the higher the impact to the business, the higher the priority that thing had to be tested, that path had to be tested. We then prioritized our features. We planned our testing to deal with a certain amount of risk beyond which the business was happy to go. Even if we hadn't tested everything, we tested the stuff that was deemed the riskiest. The problem is this kind of robs from Peter to pay Paul. In doing this risk identification prioritization, this in and of itself is a manual heavy process. Whilst it is very effective at reducing the overall amounts of testing we conduct, the planning is a bottleneck. We need to think of a better way to do it. This is where we start to think about ways we can apply an AI. AIs in any industry where they're being used for decision-making processes give us this ability to step away from know-all ninjas and mavens and subject matter experts and just make informed, qualified decisions based purely on the data of our application and paying attention to very specific foci. In other words, we don't need to ask the guy who's been the test manager for the last 25 years if this is good or bad or likely to fail or not. That doesn't mean that their insight and experience isn't valid, but maybe they would be better using that experience and insight elsewhere, and we can use the raw data from our systems to start to prioritize and inform that decision. This can be applied to any kind of decision system. In this context, one of the ones we're looking at is, can we use an AI to help us risk-based test? There's three main user cases for this, right? As a tester, I would like to know what I actually need to test based on certain changes or certain risks in my system. As a business, I want to know that enough testing has been gone, that I can clear the risk threshold, but without actually over-testing and slowing down my time to market, which would then have a negative effect on my consumer base. And as a developer, I want to know, what am I likely to affect with my change? How do I get the testers to help target their testing and work with me to review where impacts might have come in? Qualitest have started developing an artificial intelligence test predictor that takes account of the various decision systems that feed our quality life cycles, that take into account these user considerations and are starting to inform test prioritization for risk-based testing with this. We're trying to improve the speed and the accuracy of our risk-based testing by drawing on information from defect systems through to production systems, through to source control systems and test management systems. We can then turn around and say, quantitatively, this test is this likely to pass or fail in the next execution based on everything I've seen in the past. It takes away that need to manually scale and prioritize your risk. There are four main areas that you can draw information from quality health for that you can feed an AI with. There's software development systems. In other words, what's been changed at what points. There's test execution systems. what was run through, what passed, what failed. There's test management systems, how much testing did we do in different places? And then there's the production systems, how much has actually slipped right, what things were not detected. Using all of these, we can start to detect hotspots in the application. Are these modules more or less likely to fail? Are these testers more or less likely to find a defect? Are these test cases more or less likely to find a valid defect? And we don't just train one model with this. We can train multiple AI models to look at these sources of data, because different AIs will find things different ways. And then we get an interesting situation. Different AI models will come up with different levels of prediction accuracy for the same set of data. So on the left, we've got one model that was made for a system. On the right, we've got another model that was made for the same set of data. In the model on the left, we have the ability to catch 40% of our total failing tests in 10% of the testing. Now, for an organization that is trying to massively reduce the amount of test execution they do, but that has an appetite to either shift some testing further along and allow for the fact that the 61% of failures that weren't caught will be caught in something like a system test or can be fixed post-live, that's a key optimization, right? We now free up 90% of our test execution time. The model on the right is a much, much more conservative model. What we're saying here is, look, I can get you 73% of the failures based on everything I've seen before. If I run these tests through, I will find you 73% of your failing defects, just telling you what to test. But you only need to run 48% of the testing to do it. So you're running a lot more testing, but you have a much higher likelihood of getting the failing tests. For an organization that is trying to look at planning their late stage testing, something like UAT or production testing, or where they have critical safety systems that cannot be allowed to fail, this kind of a model is much more useful. In one regard, we can look to shift right some testing. We know it's going to get out at this point, but we speed up this execution cycle. In another regard, we are doing more testing here. Maybe some of it could have been shifted left, but we need to do a certain amount of execution here to guarantee that we meet our quality gates. In practical terms, one of the customers that we applied this for gave us an amount of historic data. They had roughly 1,000 test cases in a regression pack, and they gave us around about 13,000 previous run results. We trained an AI model to go over this and try to analyze where the passing and the failing test cases were likely to be based on the data we'd seen in the past. We got around about 80% accuracy on the model, and from this, we were able to effectively deprioritize 5,000 of those 13,000 executions. In other words, if they'd been using a predictive engine all along, they would have been able to save 40% of their execution time. Now, that doesn't mean that that time's not being used, but it means it doesn't need to be used on needless execution. We can start to think about using that time for better quality engineering. We can start to think about using that time to bake better quality processes. For instance, how much of my testing should I actually focus on doing here? Can I possibly refine my CI, my CD pipelines? Why is it that this particular module is so much more prone to failure? Is it because my tests are not of a suitably high quality here? Or is it because my tests are of a very high quality here, but the underlying module itself is problematic? Should there be development input into this? If I'm seeing a high propensity of automated test cases failing where the functional counterparts don't, is that because my automation is looking at the wrong things? Is that because my functional testers aren't necessarily interpreting the test case correctly? We start to take the insights we gain from a very arbitrary, is this test going to pass or fail according to what I've seen before, and we can start to feed the quality engineering and the DevOps process and further streamline and optimize our testing process. And when you put it into practice, that gives you the opportunity to see how you can choose which bits of your testing are shifted left and shifted right in an integrated pipeline.
So I'm going to just talk through how this may look like in practice. Now, what this is going to be doing is taking an approach that we've seen, walking through what a model might look like for a typical CI model, and then how AI can fit into that, just to kind of better explain how AI can fit into the testing process and what benefits that you can get from that. So to begin with, I've got this scenario of a simple CI pipeline. Now, just to explain this a bit better, what you have is you've got a developer there over on the left, you've got your production system over on the right, and what you want is a developer to be able to make a change that will go directly into production, passing through your complete DevOps process. And this is an overly simplified process. There's a lot more testing in there. But effectively what I've got is a developer, he writes a code change. There's 3,000 unit tests that run that take a minute to execute. He's got 200 integration tests or API tests that take 10 minutes to run. He's got 60 end-to-end UI level tests that take 60 minutes to run. And then what he's done is he's taken a subset of those system tests, so taken 10 of those tests, and he's running them on 4 different platforms, maybe Chrome, Firefox, iPhone, Android. And that takes 40 minutes to run before it gets into production. So this is just the beginnings of a simple pipeline. Then what you'll have is the developer can make a code change. It then executes his unit tests, and I've got a clock at the bottom just to show the time passing through this. So it's a minute later he's executed his unit tests. Then his integration tests run, they pass. That's 11 minutes that have passed. However, his system tests, these 60 tests that he's got, 2 of them have failed due to a defect in the code. And so after an hour or an hour and 11 minutes after the developer's made a change, he's been notified that he's made that he's created an issue in the system. So he goes back, fixes those issues, and it goes back through the pipeline again. And it runs through the system with everything passing, and then finally it will hit the production environment. With monitoring in the production environment, you may find out that there's been 4 defects being reported in your production environment. And let's just say they're reported straight away as soon as it goes into production. He's got that fed back. It's taken him 3 hours to get his code into the production environment. And there's now 4 defects affecting the users that were missed as part of this automated testing process. So now the developer has to fix those issues and feed the code back through the system again and put it into production to fix those defects. And again, this is a simplified model, but what you've got here is in this CI pipeline, he's spent 5 hours and 23 minutes getting his code change from his local development machine into a production environment where the users can use it and remove the defects from it. In that time, as you can see the clock on the right, the users had 4 production defects affecting them for over 2 hours. And this is where the need to reduce the test execution time comes in. And this is where changes are starting to be made. Now, one of the common changes that you do to speed this up is you then move towards a multi-threaded model. So this is rather than me having one server that runs all of these tests, I've now got 4 servers or 4 build agents. So they're running these tests, and this greatly reduces down the time spent going through this CI pipeline. So running through the same scenario in a multi-threaded system, the developer makes the changes, the tests run, the defects are found during their system testing, they fix them, they run through the process again. Again, you've still got the same 4 defects found in production. Multi-threading hasn't improved the quality, it's just improved the speed. Now the code has got into the production environment in under an hour instead of in 3 hours. But the users are still impacted by the defects. The developer still then needs to fix the issues, run through the testing process again, and get it into production. What multi-threading has effectively done is it's reduced the amount of time the developer has spent trying to get that feature into production down by 3 hours and 24 minutes. It's greatly reduced the amount of time the developer spent on that. It means the developer can be a lot more productive. It's also reduced the amount of times those defects are in production. They run in production for 49 minutes instead of over 2 hours. So this is a big benefit, and where a lot of focus is on how do we speed up our testing. But this requires adding in more servers, putting in more resources, and also having a exhaustive level of testing, which means a lot more maintenance. And this is where we can bring AI in. Now let's bring in the same model. Now to explain what's happened here, so we've ran our test predictor engine, we've got our AI model, and this has came up with tests that are consistently failing at a system level that should be shifted left. And so we've now gone from 3,000 unit tests to 4,000 unit tests. We've increased our unit test coverage based on what the AI engine is showing us, that these areas are prone to failure. We need to shift the testing left to find those issues earlier. We've also increased the amount of integration tests we've got. But we've effectively said that, and I've based this model on a prediction result of 40% of tests are failing, which means that we're now only running 40% of our integration tests and 40% of our system tests and 40% of our cross-browser tests, because we're only running the tests that we believe will fail. And bear in mind, this is just one example of how an AI model can help improve the process. Going through this same process again, we can make a code change. Now we can find the defects earlier. We've shifted some of the testing left. We're finding defects earlier. We found the first defect within 3 minutes. Allows the developer to change that. We're then finding that second defect that was found during the process again, but now this is within 17 minutes. The developer can fix that. We can push it through. We've still got the same 4 defects in production. It's not added in more tests because it's only using the test cases we have and the changes that it has. So they're still hitting the production environment. But it's only taken 33 minutes to get the code through at the same quality level that it was before. We can then fix those issues and get them into production. What this now means is we've shaved another 33 minutes off of the development time. We've taken 18 minutes off of the amount of time that defects are in production. But most importantly, our tests now adapt to the changes that the developers make. No longer are we running 100% of our tests, trying to find any potential regression that there may be. Instead, in this model, we're executing 40% of our tests. It takes 40% of the time to run through. But next time the developer makes a change, it may run a different 40% of the tests or 50% of the tests. The AI model is constantly learning from what the developers are doing, which tests are passing, which tests are failing, which issues are found in production to link them together. So this testing process is adapting to the changes that the developers made and the testing needs that exist. And this can also greatly reduce maintenance due to highlighting areas where tests never fail. And what's the point of running a test that will never fail? Especially if it could highlight there's an issue with the test. It could highlight that it's just a very stable area of code. And this doesn't mean that these 40% of tests, that's all we ever run. What this now means is this constant CI DevOps pipeline that's running through that needs to be as rapid as possible can do that. And we can shift some of the testing right. We can have it that once a night, once a week, we execute all of our tests, or we add in layers of exploratory testing or beta testing to find these issues and to run the tests that haven't been run due to running through this optimized AI engine to still get the quality engineered throughout the process and production level quality, but working at a rapid speed. And that's it from our sort of our short overview of how AI can help speed up the DevOps process and improve quality. We'll now go over to questions.
Okay, well, thank you, Daniel and Christopher. As you say, we're approaching the end of our webinar session, but we've got some time for the Q&As. And thank you to those who sent questions to us in advance. I'll go through those now. So question number 1. Can I automatically trigger my automated tests based on the AI prediction?
Sure. So the AI prediction is handled by an engine, much as anything else. And how you integrate that engine is up to you. You may want to present it through a dashboard where you can just see the information and you can say, you know, these are the tests that are going to be good, bad, etc. And I'll get a manual engineer to go through it. There is no real difference than being able to do that and then take that, wrap it, and trigger a targeted build. That was a large part of what Chris was talking through in those slides. It's not just a case of manual prioritize, deprioritize. It's a case of, well, for years we've been running a mature CI pipeline. All of my tests are tagged. They're all set in acceptable sets. It's no more than another API call with the outputs of the AI to sit around and say, you know what, just call it automatically. I'll trust that the prediction's valid.
Okay, thank you. Next question, how do we know that the AI is accurate?
So that's a great question. And the way we do it, there is a much larger question here, which gets a bit philosophical, which is how do you know any AI is accurate? There's been other stuff Qualitest have done around testing the quality of AIs in general. But one of the things that we do with this is we base this AI on a large amount of historic test data. And I'm talking, in the example we gave, there were 13,000 individual run results. What we do is we take that historic data, we chunk a certain amount of it that we're going to train the AI on, and then we reserve another part of that data, which we then use to evaluate the AI. So in other words, we test the AI on a reserved, held back set of data to be sure that we have confidence in the AI before we actually put it into production. And then for an extra layer of assurance, what we can do is, whilst we've got the AI predictions, we can also do a side-by-side. So, okay, the AI tells me that I need to run these tests and I should get 75% of my defects. Well, that means I've still got 25% of my defects I'm not going to find here. Well, how about I pick some tests out that it told me not to run, and I will see which of those actually result in something. So we can do a stratified set of tests on the remaining stuff. The other thing that we do is once the AI goes into production, it's not a one-shot. We don't train the AI and then leave it. The AI continually retrains as new executions come through. The longer the AI runs for, the more historic data it has to learn from, and the better the accuracy gets over time. So there's a few layers we do at the beginning. We use known data to evaluate the AI before we even put it in unknown data. We can manually cross-check what the AI is doing in the early stages to ensure in an acceptance test, if you will, that the rollout is correct. And then as the AI goes forwards, we are still continually training. The AI should only get smarter over time and better at these predictions.
Okay, thanks for that, Daniel. Okay, next question. Will the AI still be valid in 6 months' time?
Okay, so that kind of comes back to the point I was just making. The AI trains on an ongoing basis. If the project that you're doing in 6 months is fundamentally different, no test cases transfer across, no requirements transfer across, then you would need to retrain the AI on that project's data. But if the same project is running, the AI is learning from the same sorts of tests, the same modules of the system, the same kind of considerations, it will keep retraining as it goes through. And then you will have a continually accurate and continually re-optimizing AI.
Great. Okay, another one here. How does this add more value than automated testing of everything?
So I can jump in on that one. So what you've got is when you're doing automated testing of everything, you've got a lot of test maintenance time, and as any organization that's got to the point of having thousands and tens of thousands of tests, what you've got is a huge amount of time is spent on maintenance, a huge amount of time is spent on the execution and optimization to make sure that you're running these tests frequently, that you effectively are spending all of your time focusing on just your regression, adding tests into your regression pack and running your automated tests. And what you're not doing is spending time focusing on areas to improve, areas of testing that you may have missed. All of your time is just consumed with testing or trying to test everything, but not being smart about what's being tested. Adding in AI just gives you that additional insight into where you can improve your testing, where you may be missing areas of testing, which tests are adding value into the process.
Great, thank you. Next one, how does AI fit into new development in the Agile process?
Okay, so with the AI and new development, one of the biggest strengths to it is from a new development, you can build the AI training from day one. So obviously an AI is not as strong with no data to learn on. AIs live and die by their data, but if we consider that we're using AI optimization further down the line, what we can do is we can use the feeds and the necessary information for the AI to ensure that the data policies, the practices on that agile work go forwards. And we can also use it to track other things. We're talking about test prediction here, but that you don't have to limit the AI to that. For instance, the same rules that we're talking about here for prioritizing testing, you can also use to think about prioritizing other aspects of development. for instance, based on the AI prediction outputs, should I actually reprioritize my backlog grooming tasks for the next sprint to remove a certain amount of tech debt that has evidently turned up on these features? Should I use it to inform on the next sprint going forwards this new feature? We now need to automate this because the AI is turning around and starting to see things.
Thank you, Daniel. Okay, here's a good one. How do you know when tests should be shifted left or shifted right?
So with shift left versus shift right, this one is one where using the AI, what you'll be able to see is if you've got tests that are commonly failing at a system level, you would be looking into why are those failing, how are these defects making it through to the system level testing and not being caught earlier in the unit testing phase. And so you can start to look into how can we shift this left so these tests are no longer failing at the system level point or the integration level point, and can they be picked up at the unit level? And at the same time, so that tells you when to shift left, but when to shift right is going to be when you've got defects coming through the system that aren't being picked up. You can start to look at, okay, well, this isn't being picked up by, previous test results. This isn't being picked up by our automation. Why is this not being picked up? Do we need further level of testing at the end? And this is where you can start to look at, this issue will only be found at a system level. This issue only happens when these systems are integrated together. We need to have an end-to-end test here. And it can start to identify where there's likely going to be failures where you may not have test coverage, so that you can start to add those in to trying to strike that balance.
Okay, so we've got a couple that have been sent in during the course of this. So I'd like to take a look at some of those if we can. With an AI model telling you what to run, would you ever do a full test phase again? Would we even need the tests the AI didn't identify? So that's actually a really good question, and it hits two things. So one of them, Chris started to talk about a little bit towards the end of his section. The fact that they don't need to be run, for instance, on every build doesn't mean that you wouldn't want to run those tests in a nightly or a weekly build. What we're trying to do here is speed up the process. Some tests, absolutely, you may well want to remove from your test base. They have not found a defect in the last 25 releases. That test needs investigating. The odds are it's either a bad test, not looking at the right things, or it is an application of a component of the application that is so fundamentally stable and unchanging, it's a test that isn't really going to add any value. Whether you put that test in a do not run or whether you just completely delete it from your test base will depend on whether that feature or function is likely to be accessed again in the future. I think tests that are deprioritized, you probably would still want to run on a nightly or a weekly build. There is still a value in doing comprehensive testing of your application because there will be times when you have a cascading effect. A change here that we thought we had all the testing covered around has a knock-on effect to something over here. It's almost an emergent behavior. There are times where you do need to do a full and comprehensive regression test as a matter of good test health and good practice. Those tests don't necessarily fully go away, but they can certainly be put to a very intermittent run, and we're trying to speed up the general process of shift left, shift right, and the full CI/CD pipeline. So another one that's come in from the audience here, which information do you typically have to feed the algorithm, linkage between feature request, code change, and so on? So we talked about that a little bit on the system components slide, the four sources of information that you can feed an AI from. Generally speaking, the most valuable data is in the test management execution history. That's where the real nuts and bolts of it is, right? What was run at what points and did it pass or fail? But if you can get full linkage through requirements and defects, you start to get much more of that informed quality engineering insight. So then you're starting to get the insights that aren't necessarily directly related to test pass fail likelihood, but you're starting to get the insights along the lines of this entire suite of requirements is a bit weak. Is there a problem with the analysis or the understanding here or the comprehension? You're also getting a case of there are things that turn up in defects that have not been tested for. For instance, we've all seen a defect crop up in life because a test was never written for it. By analyzing those defects, we can pull back in. We can start to identify key parts of the application that remain untested. As a minimum, the test data is where most of the value comes from. But if we can add the pre-test information and the post-test information, the more data you have, the stronger you can build the AI to be.
And I believe that our last question that we have that I will attempt to answer is that are we saying that there's going to be more testing after the code is moved to production or before it's moved to production, and whether that's done by the AI? So with regards to whether there's more testing before or after moving to production, it's not necessarily of whether it's more testing after. It's more of a case of prioritizing and optimizing your testing before it goes into production to try and find the defects in the least amount of testing, but without having to do a manual risk-based testing approach, instead using the AI to do the risk-based analysis. This does mean that there is a higher likelihood of defects moving into production, which means that you will have effectively a higher level of testing in production, but providing you've got strong monitoring of your production environment, and due to this optimized pipeline and a risk model that's working for you, bearing in mind that you will likely always run your higher priority tests, whether they're predicted likely to fail or not, your absolute P1s. You don't want your payment engine to go down. So you will still run these tests. So what you will have is, instead of you testing everything before production, you are doing more testing or more monitoring of your production environment to have it that you can fix these issues quickly. With this prioritized engine, you can fix defects in a matter of minutes rather than hours or days. And with regards to doing the AI doing the testing, the AI itself isn't doing the testing in this scenario. There are AI engines out there looking at testing systems, but the model we're talking about here and in this webinar has been using AI to predict the likelihood of your tests passing or failing and the value added from those tests, rather than actually, it's not executing the tests. You're using that information to feed the execution engine.
We're not replacing all the testers with robots just yet. Okay, I think that's about all we've got time for. Thank you very much for joining, guys, and thank you to Chris for co-hosting with me. And we will hear from you soon.
Yeah, thank you. And again, thanks everyone for your questions, and we look forward to seeing you next time. So until then, goodbye.
Thank you. Bye.